All right, so we are on polynomial expressions, factoring polynomial expressions, lesson 6. So, as always, we start with a little bit of a review. So 2x plus 1, 3x plus 4. If we expand and simplify, we get 6. Oops, sorry. We get 6. Let's shrink down my size here. 6x squared plus 11x plus 4. And so essentially what we're saying here is that we can go back and forth from our 2x plus 1, 3x plus 4, back and forth to this form. So we can go back from 6x squared plus 11x plus 4. All right, and we can factor that to get 2x plus 1, 3x plus 4. Likewise, we can take 3x minus 2, 4x plus 3, and we can end up with 12x squared plus x minus 6. Again, to do that, you would just use distributive method or your FOIL method, okay? And that's what we would come up with. So you can take that expanded form, 12x squared plus 6, plus x, sorry, I don't know why I put 6 here. This is plus x minus 6. Just like that, we can get back to 12x squared plus x minus 6. So here's our problem. What are the factors of 2x squared plus 7x plus 6? We need to find two binomials whose product is 2x squared plus 7x plus 6. So, of course, as always, they're going to ask you to start using algebra tiles. So here we go. We've got 2x squared plus 1, 2, 3, 4, 5, 6, 7x plus 1, 2, 3, 4, 5, 6. So 2x squared plus 7x plus 6. All right, and so what it wants us to do is arrange it into algebra tiles. So with a little bit of fiddling, we end up with something like this. 1, 2, 3. So there's our 2x. 1, 2, 3, 4. There's 4 of our 7x. 5, 6, 7. 1, 2, 3, 4, 5, 6. And of course, all of this is shaded in. Okay, so we get something like this, and this allows us to find our two sides. So the length of ours here is 1, 2x plus 1, 2, 3. 2x plus 3. Our width here is x plus 2. Right? We've got an x here, and we've got 1, 2 there. So there's our width. And then our length here, we got 1, 2, x, and 1, 2, 3. So there's our length there. So we can use algebra tiles to solve this. We just got to fiddle and arrange. So if we were to express it as a polynomial in factor form, we would say 2x squared plus 7x plus 6, which was our original one, is the same or is equal to 2x plus 3, x plus 2. All right, so straightforward there, just a little bit of a review. Now we're going to do the same thing, okay, just a different one, and we're going to use algebra tiles. So we're going to try and find 5x squared plus 7x plus 2, and we're going to use algebra tiles. So here we go. Let's put together all our 5x squared. 1, 2, 3, 4, 5. I'm just going to redo that one because we can do that one better. 5. All of those, of course, are shaded. Okay, 5x squared plus 7x. So we're going to go 1, 2, and then 3, 4, 5, 6, 7. Of course, all of those shaded. Plus 2. Okay, so we end up with 5x squared plus 7x plus 2 gives us 1, 2, 3, 4, 5x plus 1, 2. So we get 5x plus 2. And then on the other side, we've got x plus 1. Those are our two sides there. So we were able to factor this guy. So it says factoring algebra tiles will work for all trinomials in the form of a x squared plus bx plus c, which have binomial factors. However, it can get rather tedious if a, b, or c, so this guy, or this guy are large. Can you imagine if you had 24x and had to draw out 24 tiles? That doesn't make a ton of sense at all. So what we're going to do instead is we are going to figure out methods on how we can do this. So the first thing we're going to do is grouping. So we've done grouping before in past ones where we said, okay, we're going to group one side of our equation. So we're going to group everything on this side, and we're going to group everything on this side, and we're going to factor those first. So let's do this one first. So with 6x squared plus 3x, okay, we're going to find the greatest common factor. So in this case, it's 3, and greatest common factor of x is x. So x squared and x. So we're going to pull out the 3x, and that's going to leave with 2x plus 1. Okay, and then on this side, we've got a positive there. We're going to find the greatest common factor between 8 and 4, which is 4. We can't take out an x because it doesn't exist over here. So it's going to be 2x plus 2. Or sorry, plus 1. Because we pulled out the 4. 2x plus 1. All right. So now we have the same binomial here and here. So we can rewrite this as 2x plus 1 times 3x plus 4. Okay, same thing on this one here. Okay, we're going to group the ones that make sense. So in this case, we might have to rewrite because it kind of makes sense to group our x squared, 12x squared, and our 8, as well as our 9 and our 6, but we could do whatever we want here. So let's do it this way first. Let's do, what do we want to do? Let's leave it as is. Let's leave it as is here. So we're going to group, We're going to group when we group them all. We're going to group this side here. Come on. We're going to group this side here, and we're going to group this side here. So here's our groups. So 12x squared and 9x. We have an x that we can pull out. 12 and 9. The greatest common factor there is 3. All right, so we are left with 4x plus 3. And then on this side, 8 and 6. Greatest common factor of those two is 2. So we are left with 4x plus 3. This is perfect because this and this are the same. So we can go 4x plus 3 times 3x minus 2. All right, so we factored those out with grouping. Okay, so the next method that we're going to talk about is the method of decomposition. Okay, method of decomposition, and we're going to get a little bit of a roundabout way here to explain. In warm-up 2, we factored this. So we said 6x squared plus 3x plus 8x plus 3x plus 4. We factored that. Really, what we did is we added these two like terms together. So our 3x and our 8x, and we got 6x squared plus 11x plus 4. And we got this. Okay, so I'm going to continue this in the next video. We'll pick up right where we left off. All right, so hang tight.